The universe may look calm when we observe the night sky, but in reality it is a place of constant motion. Every star, every planet, and every galaxy is moving through space at incredible speeds. Even our own galaxy is not standing still. The galaxy we live in, the Milky Way, is currently traveling through space at hundreds of kilometers per second, and it is not moving randomly. It is being pulled by the gravity of nearby galaxies. One of those galaxies is our closest large neighbor, the Andromeda Galaxy. Right now, Andromeda is located about 2.5 million light-years away from Earth. That may sound unimaginably far, and in human terms it certainly is, but on a cosmic scale, it is actually very close. And something extraordinary is happening between these two galaxies. They are slowly moving toward each other. Astronomers have measured the motion of the Andromeda Galaxy very carefully using powerful telescopes and advanced instruments that detect tiny shifts in light. These measurements reveal a surprising truth. The Andromeda Galaxy is approaching the Milky Way at a speed of about 110 kilometers per second. That may not sound extremely fast, but remember that galaxies are enormous structures. Each one contains hundreds of billions of stars, along with gas, dust, dark matter, and planetary systems. When objects this large begin moving toward each other, the result can reshape entire regions of the universe. Scientists now believe that in about 4 billion years, the Milky Way and Andromeda will collide. But when we hear the word collision, it might create the wrong image in our minds. Galaxies do not crash together like two solid objects. In reality, galaxies are mostly empty space. Even though they contain hundreds of billions of stars, the distance between individual stars is so vast that direct stellar collisions are extremely unlikely. Instead, what will happen is something much more complex. As the two galaxies approach each other, their enormous gravitational fields will begin to distort their shapes. Long streams of stars and gas will stretch outward into space, forming gigantic arcs known as tidal tails. Some stars may be thrown far away from their original positions. Others may be pulled into new orbits around the combined gravitational center of the merging galaxies. Over millions of years, the structure of both galaxies will gradually change. Spiral arms will twist and warp, clouds of gas will collide and compress, triggering massive bursts of new star formation. Entire regions of space may light up with brilliant clusters of newborn stars. This process will not happen quickly. In fact, the full merger between the Milky Way and Andromeda will take billions of years to complete. Astronomers believe the first close encounter between the galaxies will occur roughly 4 billion years from now. During that moment, the two galaxies will pass through each other, stretching and distorting their structures. Then gravity will pull them back together again. Then may repeat this process several times, approaching, separating, and approaching again, until they finally merge into a single massive galaxy. Scientists have even given this future galaxy a name. They call it Milkomeda. This future galaxy will likely be much larger than either of its parent galaxies. It could contain over 1 trillion stars, making it one of the most massive galaxies in our region of the universe. But what would this event look like from Earth? Surprisingly, the view of the night sky could become even more spectacular. As Andromeda approaches over millions of years, it will gradually grow larger and brighter in our sky. Eventually, it could appear as a massive glowing structure stretching across a large portion of the heavens. Billions of new stars may form during the merger, lighting up the sky with brilliant clusters and nebulae. However, there is another factor that will affect the future of our planet. By the time the galaxies collide, the sun will also be approaching the end of its life. Stars like the sun slowly grow brighter and hotter as they age. In about 5 billion years, the sun will begin transforming into a red giant. During this phase, it will expand enormously, possibly engulfing the inner planets of the solar system. That means Earth itself may not survive long enough to witness the final stages of the galactic merger. Still, the story of the Milky Way and Andromeda collision tells us something profound about the universe. Galaxies are not permanent structures. They evolve, interact, and sometimes merge with each other to form entirely new cosmic systems. In fact, astronomers believe that many of the large galaxies we see today were formed through a series of past mergers. Our own Milky Way may already be the result of several ancient galactic collisions that occurred billions of years ago. Even today, our galaxy continues to absorb smaller satellite galaxies. One example is the Sagittarius dwarf galaxy, which is currently being stretched apart and gradually consumed by the Milky Way's gravity. Streams of stars from this smaller galaxy are already spreading through our galactic halo. These remnants serve as evidence that galaxies grow by merging with others over time. But the upcoming collision with Andromeda will be on a completely different scale. Two giant spiral galaxies, each containing hundreds of billions of stars, will combine to create a new cosmic structure. It will be one of the most dramatic events in the future history of our local universe. Yet despite its immense scale, this collision will likely unfold in silence, because space is vast, and the distances between stars are so great that even during a galactic merger, most stars will simply pass by each other. But gravity will quietly reshape their orbits, slowly building a new galaxy from the remains of the old ones. And this raises an intriguing question. If galaxies are constantly merging and evolving, what will the universe look like in the distant future? Will Milkomeda remain stable, or will it one day collide with yet another galaxy? As it turns out, the Milky Way and the Andromeda Galaxy are not the only major members of our cosmic neighborhood. Both galaxies belong to a gravitational family of galaxies known as the Local Group. This group contains more than 50 galaxies, most of them small dwarf galaxies orbiting the two giants. Together, these galaxies form a gravitational system that stretches across roughly 10 million light-years of space. At the center of this group, two galaxies dominate everything else: the Milky Way and the Andromeda Galaxy. Andromeda is actually larger than our galaxy. It contains roughly 1 trillion stars, while the Milky Way contains somewhere between 100 and 400 billion stars. Because of its greater mass, Andromeda's gravitational pull is extremely powerful. For billions of years, the gravity of these two galaxies has been slowly drawing them closer together. But their collision will not happen in a single dramatic moment. Instead, it will unfold over an almost unimaginable span of time. The first visible changes will begin long before the galaxies actually touch. As Andromeda approaches, its gravitational pull will start to disturb the outer regions of the Milky Way. Stars near the edges of both galaxies will begin to feel competing gravitational forces. Some stars will shift into new orbits, others may be flung outward into intergalactic space, becoming what astronomers call rogue stars, stars that wander alone between galaxies. Meanwhile, enormous clouds of hydrogen gas will begin to interact. These clouds are the raw material from which stars are born. When two large gas clouds collide, they compress and collapse under gravity. This process can ignite waves of star formation across entire regions of a galaxy. During the merger of the Milky Way and Andromeda, astronomers expect massive bursts of star formation known as starbursts. Entire clusters of new stars may form within relatively short cosmic periods. Some of these stars could be incredibly massive, dozens of times heavier than our Sun. Massive stars live short but violent lives. Within just a few million years, many of them explode as supernova. These explosions release enormous amounts of energy and scatter heavy elements across space: iron, oxygen, carbon, and many other elements that make up planets, and even life itself, are forged inside stars and released during supernova explosions. So in a sense, galactic collisions help recycle the material that eventually forms new planets and possibly new civilizations somewhere in the universe. But what about our own solar system? What will happen to Earth during this cosmic event? The answer might surprise you. Even though billions of stars will move through new gravitational patterns, the chance that the Earth will collide with another star or planet is incredibly small. The average distance between stars in our galaxy is about 5 light-years. To understand how large that distance really is, imagine shrinking the Sun down to the size of a grain of sand. The nearest star would still be several kilometers away. Because of these enormous distances, most stars in both galaxies will simply pass by each other without any direct collisions. However, gravity may still alter the orbit of our solar system. Some simulations suggest that the Sun could be pushed into a new region of the merged galaxy. Instead of remaining in the relatively calm outskirts of the Milky Way, our solar system might end up much farther from the galactic center, or possibly closer. There is even a small possibility that the solar system could be ejected into intergalactic space. If that happened, the night sky would look completely different. Instead of seeing the bright band of the Milky Way stretching across the sky, the stars would appear much more sparse. Our galaxy would shrink into a distant glowing cloud far away. But there is another fascinating detail about the collision between the Milky Way and Andromeda. Both galaxies contain supermassive black holes at their centers. At the center of the Milky Way lies Sagittarius A. This enormous object has a mass about 4 million times greater than the Sun. Meanwhile, The center at the Andromeda Galaxy hosts an even larger black hole. When the galaxies merge, these two supermassive black holes will eventually begin orbiting each other. Over time, they will spiral closer and closer together. Finally, they will merge in one of the most powerful events in the universe. When two supermassive black holes collide, they release enormous ripples in the fabric of space and time. These ripples are called gravitational waves. Such waves were first detected in 2015 by scientists working with advanced observatories. But the merger of two galactic black holes would produce gravitational waves on a scale far greater than anything humanity has observed so far. If intelligent civilizations still exist in the distant future, they might detect these waves traveling across the cosmos. For them, it would be a signal announcing the birth of a new galaxy. After billions of years of chaotic motion, tidal distortions, and star formation, the two galaxies will finally settle into a stable shape. But that shape will no longer resemble the elegant spiral structures we see today. Instead, the result will likely be a massive elliptical galaxy. Its stars will move in many different directions, creating a more spherical and less organized structure. Astronomers sometimes refer to this future galaxy as Milkomeda. This giant galaxy will dominate the local group. Most of the smaller galaxies nearby will eventually be pulled into it as well. Over trillions of years, Milkomeda could slowly consume nearly all the galaxies in its region of space, and that leads us to one final thought. Right now, when we look into the night sky, we see countless galaxies scattered across the universe, but the universe itself is expanding. Distant galaxies are moving away from us faster and faster due to a mysterious phenomenon known as dark energy. Because of this expansion, billions of years in the future, many distant galaxies will disappear beyond the observable horizon of the universe. Eventually, Milkomeda and the remaining galaxies of the local group may become isolated in the vast darkness of space. Future astronomers living inside that galaxy might not even know that other galaxies once existed. To them, the universe could appear as a single enormous galaxy surrounded by empty space, and they might never realize that billions of years earlier, two great spiral galaxies, the Milky Way and Andromeda, once drifted toward each other across the darkness of space, slowly beginning one of the most extraordinary cosmic events in the history of the universe.